Today's lesson will introduce you to the basics of slope. Your learning target says, I can identify the slope of a line from a graph or table and use it to write the equation of a line. There are actually 4 different types of slope: positive slope, negative slope, zero slope, and an undefined slope. So on about half of your piece of paper, I want you to draw this graphic. So this is a Freyer diagram where you have 4 parts with your types of slope in the center. Put positive slope in your upper left-hand corner and leave some space for a graph. Negative slope in the upper right-hand corner, again leave some space for a graph. Zero slope in the lower left, and undefined slope in your lower right. And go ahead and pause me while you get your paper set up. So we're going to start with the positive slope box. That's in your upper left corner. And so here I have some ordered pairs for us. We're going to graph these and determine that this is actually a positive slope. So I've already told you it's positive. We don't need to determine that, but we'll talk about why it's a positive slope. So my first ordered pair is 2, 1. So I'm going to go over 2, up 1, and make a dot. Second is 3, 3, over 3, up 3. Third ordered pair is over 4, up 5. And last pair is over 5, up 7. So I'll pause here for a second after I've drawn in my line the best I can so that you can catch up with me. So go ahead and pause, catch up with me, and then come back. All right, so this is a positive slope. If you notice on my slope, it's looking like we are heading uphill. So as my let me change this. So as my y increases, my x is also increasing. So when they are both increasing, I have a positive slope. Okay, so we're ready to work on your negative slope. All right, so we don't have to determine what type of slope because I told you what kind it was. If you would prefer to graph before me, pause me now. If you want to graph with me, we'll do it together. And you could always pause after I'm done in case I go too fast for you. All right, so we have our first ordered pair is -6, +2, which is about right here. -4, 0 is right here. -2, -2 is right here. 0, -4 is here, and 2, -6 is here. So if I went too fast for you, got to draw my line. Feel free to pause me and catch up. Excuse me. So this one, if you look at it, it looks like we're walking downhill. So what's happening actually is that our y coordinate is decreasing, while our x-coordinate is increasing. And when you have opposites like that, if you look down our y-coordinate side, notice this is getting smaller, 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 but our x-coordinate is getting bigger, 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 bigger. When you have it opposite like that, you're going to end up with a negative slope. Okay, zero slope. Again, we don't have to determine. I told you what kind of slope it is. And you have a couple of options. If you'd like to pause me now, you can graph before me. If you want to graph with me, we'll do it together. And if I go too fast, make sure you pause after so you can get caught up. All right, first ordered pair is -6, 4, and that's going to be about right here. -3, 4 is right here. 0, 4 is here. 3, 4 is there. And 6, 4 is there. So I'm going to connect. If I went too fast for you, pause and get caught up. Okay, so this one, when we do slope, we're actually looking at the rise over the run. Now, we've talked about this in previous lessons. We thought about it as a change in y over a change in x. And so if we look at our y's, 4, 4, 4, 4, 4, there is no rise. It's not going up. It's staying horizontal. So it doesn't really matter, excuse me, what's happening to our x. I can just put an x down there. It doesn't matter because whenever you take 0 divided by any number, you're always going to get 0. So as long as 0 is your numerator, or in this case you have a horizontal line, you will have a 0 slope. Okay, our last type of slope is undefined. All right, so we don't have to determine what kind it is. I told you. If you'd like to pause me now and graph before me, go ahead. If you'd like to graph with me, we'll do it together. And if I go too fast, you can pause after and get caught up. All right, so let's do this first one. -5, 6 is right here. -5, 3 is here. -5, 0 is there. -5, -3, and -5, -6. Connect. If I went too fast for you, you can pause and get caught up. Okay, so thinking back to our previous lessons, we've been talking rise over run, or when we did constant rate of change and direct variation, we thought about it as a change in y over a change in x. Well, here's our y's, but I'm really more interested in what's going on with our x's. Notice our x is -5, -5, -5, -5, -5. It is not changing at all. And so it really doesn't matter in this case what's happening to the y value because, remember this is a division sign, anything divided by 0 is undefined. Those are the cases where the universe is going to explode. You cannot divide by 0. And so because my 0 is in my denominator, I have an undefined slope. So any graph that is vertical will be undefined. So really on the first part of this lesson, I simply want you to know that when you're looking at a graph, you can determine what kind of slope it is, not calculating the slope, just knowing is it positive, negative, 0, or undefined. Okay, so this is the note sheet that you should have grabbed or will need to grab from me to write on. So in the middle of your Freyer model on your note page, you see something called what is slope. Slope describes the steepness of a line. When we were doing rate of change, when we were doing direct variation, and now when we're doing slope, we're really talking about the change in y as your numerator over your change in x. So we've done this a few times already. We were just calling it by something different. Traditionally, people call it rise over run. But the rise is simply your up and down difference, and your run is your side to side. So really it's no different than a change in y over the change in x. So in the upper left-hand corner of your note page, you have a section called From a Table. And so I want you to fill in your notes. It says find the constant rate of change of the x and y values. In other words, we're going to find the change in y over the change in x. So given a table, I'm really just finding our rate of change and calling it slope. We're going to write our slope as a ratio in simplest form. All right, so let me give you some tables. On this first one, let me put these in. You're copying, of course, in your notes. 3, 6, and 4, 8. And then copy this table as well. You can pause me in just a second when I'm all done. 3, 4, 6, 8, 9, 12, 12, 16. So pause me and get caught up, and then come back when you're ready to move on with me. Okay, so to find my slope, which we're going to call M, I'm going to use change in y over change in x. So it looks like I'm skip counting by what? Every time. Okay, good. I'm adding 2 every time. That's my numerator. On the x side, it looks like I'm adding 1 every time. That's your denominator. And voila, you have just found the slope from a table. I want you to do the second table without me. So pause me now, find the slope from this table, and then come back for checking. All right, so we need the change in y over the change in x. It looks like we're adding 4 every time. That's my numerator. And my denominator is a 3. So my slope is 4 over 3. And you just found the slope from a table. In your upper right-hand corner of your note page, we're going to find slope from a graph. So we're going to choose 2 points on a line. It does not matter which 2 you pick. We're going to count the rise, or how much it goes up or down, over the run, side to side. And again, we're going to write our slope as a ratio. Oop, that's ratio in simplest form. All right, I can pick any 2 dots I want. I think I'm going to pick this one, and this one. But I could have chosen any I want. And so all I'm doing is I'm counting my rise. I'm going up 1, 2, 3, 4. That's my numerator. And then I'm counting over 1, 2. That's my denominator, but it's not in simplest form. In simplest form, I would have 2 over 1. Now, what if I had picked 2 different dots? For example, what if I picked this one and this one? Well, I still would count up 1, 2, and over 1, and I'd have 2 over 1. What if I chose this one and this one? Well, I would count up 1, 2, 3, 4, and over 2, I'd still have 2 over 1 in simplest form. So it doesn't matter which dots you choose. And again, we did that when we did rate of change, so it's not really any different. In the lower left-hand box, we're going to find the slope from an equation. So we might have to do some algebra magic here to make it work out for ourselves. We are going to solve the equation for y. It may not be y equals blah, 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 so we have to put it into that form. Slope is the rate of change. Therefore, it is next to the variable. In the past, we've called that our coefficient. And our famous equation, y equals mx plus b, is the format we are looking for. So let me give you a problem. Let's do y equals 1/2 x plus 4. If slope is our rate of change, our multiplier, our direct variation, our coefficient, whatever you want to call it, where would you find it in this equation? I believe you'd find it right there, which makes our slope equal to 1/2. So that was just a look and see. Look at it and see what your coefficient is. There it is. There's your slope. Here's another one. Let's try this one. Y equals -3x minus 2. I'm looking for my rate of change, or my multiplier, or my coefficient, or my slope, whatever you want to call it. See if you can find it. It appears to be right there. So this was another look and see. Now here's the thing. I realize it's supposed to be a ratio, but for the most part, when people are talking slope, they don't put the 1 under there. They just leave it -3. All right. Well, things can't stay quite that easy. Sometimes you have a crazy thing like this. Plus y equals 4. And I want to know what the slope is. I can't just look at that and decide, because it's not in slope-intercept form. It's not in the right format. I don't see a y equals mx plus b anywhere. So let's do some math magic here. So way back 2 units ago, we learned how to distribute. 2 times x is 2x, and 2 times 8 is 16. I'm going to bring down my plus y. I'm going to bring down my equals 4. I want this guy by himself, but I have to get rid of all this stuff. So to do that, I think I might want to get rid of my 2 x's first. Whatever I do to one side, I'm going to do to the other. This cancels. And I'm left with 16 and a y on one side, -2 x's and a 4 on the other. I still have this guy bothering me over here, so I think I would like to subtract 16 from both sides. That's gone now. And now I have y equals -2x, and 4 minus 16 is -12. Now it looks like the format I'm supposed to have. I have a rate of change, I have a coefficient, I have the multiplier, whatever you want to call it. It's right there. Your slope is -2, but to find it, you had to do some algebra magic. All right, you have one box left, and actually, here's my arrows. Skip this box for right now because this is called point slope form, and we're going to do that in a later lesson. The last 2 slides I have for you are just graphics. So if you wanted to remember the types of slope, so these are types, this graphic might help you. Positive, remember we're going uphill. Negative, we're going downhill. 0 is horizontal, and undefined is vertical. Or you could look at slope man. If you're going uphill, it's positive. If you're going downhill, it's negative. If you have a vertical line, it is undefined. And if you have a horizontal line, it is 0. These are just graphics to help remember the types of slope.